All right, so this is the Urban HydroLink, and it's meant to be played with, but since we're in this video, I'm just gonna play with it and you can use your imagination. The point is to give a bit of a representation of a pretty typical urban water and wastewater system. So the first part of any system is your source, and in this scenario, we have a surface water source. So this basin here is representative of the river. And we have to get the water out of the river and into the system, which we use a pump for. So we're gonna pump this. And the first step is it goes into what we call a flocculation basin. So I want to stop it or else it might overflow. And what's happening in the flocculation basin is that we're going to try to drop out some of the sediment. So there's usually something that is added, which causes there to be a coagulation. So you add a coagulant, and then there is usually something that turns inside to mix it all together until the sediment gets large enough and drops out. The next step is that we're going to go into a water filtration. So I'm going to add a little bit more water into the system, and you can see it's transferring over here. And as it's going through this water filtration, we've got different layers, and one of the most important is what we call anthracite. Anthracite is like a very high grade coal, really. So it's made of carbon. And you can think about maybe your Brita filter or something that you might have in your refrigerator. That is anthracite. And, oh, we're overflowing. So we're going to turn this pump on to go up here. But I'll explain that for a second. So after it gets filtered, then there are different chemicals that get added to the system. Usually there is chlorine, and in a lot of systems there's fluoride added. Fluoride is a bit of a controversial chemical that's added to the system, but that's another conversation. So after the chemicals are added, it actually goes through a series of baffles. Those baffles are inside what we call a clear well. After it leaves the clear well, it's disinfected, it's clean, good water to drink. Then it gets pumped into a central storage. So I'm going to turn this pump back on for a second, and we'll pull some more water out of the system until we get it into a water tank. Sometimes these water tanks are, and then we're going to turn this off so that we've got some water in here. Sometimes these water tanks are actually underground, but one of the main reasons they're up high is now this water is pressurized. So we don't really need any pump to move the water from the water storage. So come in and see the water storage into our usage. So we use water for lots of different reasons. So that's what it would be in there. And we can open this valve, and this valve is gonna move water. It's gonna go underground because we travel, and then it ends up getting used. So here we have a toilet and we have a bathtub. We also have a hydrant where a little bit of water can come out. So all of these systems are pressurized with gravity and are used in our household. After we use the water, we usually just kind of forget about it. Because most of the time, if you peek underground, around here, there's a whole piping system that we don't see, and it goes into a wet well. What we do see on top is actually something like this, where we see that it's our sewer system. So that collects into the wet well, and then it gets pumped off. So we're gonna turn on another pump, and that's gonna move the water out of the wet well into the water treatment. Now sometimes, I'm about to overflow this. Let me open it. So that's kind of part of the fun. Sometimes you can overflow things with this Urban HydroLink. Hopefully we don't overflow things in our regular system, but you can imagine that sometimes when we have a hurricane or there's flooding, this is actually what happens. If the pumping system isn't working or there's too much that comes into the system at once, we get what we call like a wastewater failure. You can imagine where this is problematic. So we'll come back to the system and imagine that it's all working great, where we're gonna have our primary treatment. So after the wet well, it comes in, it gets screened for all the really large particles, things that end up in the wastewater system that really shouldn't be there, you can imagine. And then it gets settled out. So again, we're trying to get the larger particles settling down, and then from the middle, we're gonna pull, and we do what we call a secondary treatment. This is where we start to have to know a bit about biology. So in secondary treatment, what we do is we actually add a lot of air. And what we're trying to do there is we're promoting the aerobic bacteria. And what those aerobic bacteria do is they get to the different nitrates in the water and they start breaking it down. And so those bacteria are actually beneficial in helping to clean this wastewater. After it leaves a secondary treatment, sometimes it goes to an anaerobic system, which we would call like a tertiary treatment, and we don't really have that represented here. Sometimes it might get a UV treatment. UV can also be used in our water treatment side, and the UV is just a further way to make sure that none of these bacteria are being passed along in the system. One of the things that's not really dealt with here might be some of the different chemicals or pharmaceuticals that are coming out of our usage. So that is another topic of conversation of how do we really manage some of the things that are in our water system that are not actually being dealt with by the bacteria. So after the bacteria work through the wastewater, it comes into a process where it's usually, sometimes it's put through a membrane filter. So I'm going to open up this valve. Oh, it is opened. And then it gets some chlorination. So we're adding more chemicals to it. Again, we're looking at bacteria. And these little steps are meant to represent what we would call aggregation. And that agitation is going to like mix up the water. And that just helps to kind of get the chlorine a bit out of the water before it goes back into our surface water. Which then, if we come a little bit along here, if we can imagine downstream, there's another community that has a pump that's going to turn on their pump. And they're going to do the same process. So which means that unless you're at the top in what we would call the headwaters, then you're probably drinking water that at one point in time went through this system before it got to you, which means that it was in someone's household and went through a wastewater treatment and now is being treated at this level. So it's something to consider in thinking about what we put down our drains, is that that's going to be happening downstream. So it's just another way to say, like, we are all connected in our water and wastewater systems, and we can be mindful. So again, this is the Urban HydroLink, and it's just a representation, and perhaps someday you can come and play with it yourself.